Tonight, we're going to explore a truth that defies what your eyes tell you when you look at the night sky. Look up on a clear night, away from city lights, and you'll see thousands of stars. The Milky Way stretches across the sky like a river of glowing cosmic dust. It's beautiful, it's grand, and it creates a powerful illusion, the illusion of abundance. All that light, all those stars. Surely the universe must be packed with destinations. Surely it's just a matter of time, engineering, and human willpower before we bridge the gaps and claim our place among them. We have been conditioned by decades of science fiction to view the cosmos as an upcoming frontier. We watch starships engage warp drives, tearing through the fabric of space-time to drop into a new solar system within seconds. We grow up believing that space exploration is a linear progression. First the moon, then Mars, then the stars. We treat the interstellar gulfs as mere engineering hurdles, problems that will inevitably yield to larger rockets, exotic fuels, and the relentless march of human ingenuity. But when scientists measure reality on the largest scales, they discover something deeply unsettling, something that borders on terrifying. Almost everything is missing. The distances separating us from the rest of the cosmos aren't just large, they are conceptually violent. They are distances that don't just challenge our technology, they render the very idea of interstellar travel completely obsolete. The physics of our universe tells a story where space is actively expanding, where energy is fading, and where humanity might already be trapped in a cosmic quarantine from which there is absolutely no escape. We tend to think that if we could just build a ship fast enough, perhaps approaching the speed of light, the universe would open up to us. But the speed of light, which we view as the ultimate cosmic speed limit, is actually our greatest cage. When you apply calculus, relativity, and observational astrophysics to the scale of our universe, you realize that nature has built walls around our reality. We reside in a specialized window of time where we can see the grand architecture of the cosmos, but we are mathematically forbidden from ever touching it. By the end of tonight, you're going to understand the true, uncompromising scale of cosmic emptiness. You'll see why our nearest stellar neighbors are deceptively distant, why the expanding universe is actively tearing our future destinations away from us, and why interstellar travel isn't just difficult, it is physically and mathematically obsolete. Before we dive into the deep dark of the cosmos, if you love exploring the hidden mechanics of space and existence as much as we do, take a second to like this video and subscribe. It's a simple action, but it helps this channel reach more curious minds like yours. Welcome back to Dark Matter Nap. Now, settle in, clear your mind, and let's begin our journey into the absolute nothingness. Let's start with what you think you know about space travel. When we look back at the absolute peak of human achievement in space, our minds immediately go to the Apollo missions. Human beings sitting atop controlled explosions, breaking free of Earth's gravity, and walking on the surface of the moon. The moon is roughly 240,000 miles away. To a human being, that is an immense distance. If you hopped into a commercial airliner and flew at 500 miles per hour without stopping, it would take you nearly 3 weeks of continuous flight to reach it. The Apollo astronauts traveling in command modules that topped out at over 24,000 miles per hour crossed that gulf in about 3 days. But on the cosmic scale, the moon is touching us. It is practically inside our own planetary atmosphere. If Earth were scaled down to the size of a standard basketball, the moon would be a tennis ball placed just 24 feet away. The International Space Station, where humans live for months at a time, would be orbiting less than an inch away from the surface of that basketball. We have barely even stepped off our own porch. Now let's expand our view to our next-door neighbor, Alpha Centauri. Located just over 4.3 light-years away, it is the closest star system to Earth. In the grand tapestry of an observable universe that spans 93 billion light-years, 4.3 light-years sounds like a microscopic hop. It's our immediate cosmic backyard, but let's convert that hop into numbers that human brains can actually comprehend. Alpha Centauri is roughly 25 trillion miles away, 25 million miles. It is a number we can write down, but one that our evolutionary wiring completely fails to visualize. To understand the absolute brutality of this distance, let's look at Voyager 1. Launched in 1977, Voyager 1 is the farthest human-made object from Earth. For nearly 50 years, this spacecraft has been screaming through the dark at an incredible speed of over 38,000 miles per hour. It has crossed the boundary of our solar system, leaving the heliosphere behind, and has entered the cold, unshielded expanse of interstellar space. If Voyager 1 were headed directly toward Alpha Centauri, which it isn't, do you know how long it would take to get there? Close to 75,000 years? 75,000 years. To put that in perspective, 75,000 years ago, Homo sapiens were sharing the planet with Neanderthals. We hadn't invented agriculture. We hadn't built cities. We hadn't written a single word. That is the time required for our fastest operational spacecraft just to reach the nearest star. If you attempted this journey in a standard automobile, traveling at a continuous 60 miles per hour, it would take you roughly 48 million years. This is the reality of our immediate neighborhood, and Alpha Centauri is just a single point of light. Our own Milky Way galaxy is 100,000 light-years across. If we wanted to travel to the center of our galaxy to see the supermassive black hole, Sagittarius A, even traveling at the speed of light, 186,000 miles per second, a speed that allows you to circle the Earth 7 times in a single second, it would take 26,000 years. We look at the night sky and see a crowded ceiling. In reality, we are looking at a cosmic desert where the oases are separated by infinite oceans of absolute, unyielding nothingness. When faced with these impossible distances, the optimist always says, but what about better technology? We will move past primitive chemical rockets, we will build fusion reactors, harness antimatter engines, or use high-powered lasers to push light sails across the void. Let's indulge that optimism. Let's imagine a future where humanity has mastered the absolute upper limits of known engineering. We construct a starship powered by antimatter annihilation, the most efficient fuel source theoretically permitted by the laws of physics. This ship doesn't drift at the sluggish pace of a chemical rocket. It accelerates continuously until it reaches 99% the speed of light. On paper, it looks like the problem is solved. If we are traveling at 99% the speed of light, Alpha Centauri is just a 4-year trip. The star systems within our local stellar cluster suddenly become accessible within a standard human working career. But this is where Albert Einstein and the unforgiving laws of relativity step into the room, and the cosmic rulebook does not bend for anyone. As an object with mass accelerates closer to the speed of light, an incredible and brutal mechanic of the universe takes over: relativistic mass increase. According to Einstein's famous equation, E equals mc squared, energy and mass are two sides of the same coin. When you pump massive amounts of energy into a starship to make it go faster, that energy ceases to increase the ship's velocity linearly. Instead, it begins to manifest as mass. The faster you go, the heavier the ship effectively becomes. This means that to push the ship just a fraction of a percent faster requires exponentially more energy. By the time you reach 99.9% the speed of light, the ship's effective mass approaches infinity. To accelerate a modest-sized colony ship past this point would require more energy than the entire planet Earth has produced across its entire geological history. You run into a wall of diminishing returns that no amount of advanced engineering can bypass. And even if you magically solve the energy problem, space itself becomes your ultimate executioner. Interstellar space is not completely empty. It is filled with a thin haze of hydrogen atoms and microscopic dust grains. At normal speeds, this interstellar medium is completely harmless. But when your ship is traveling at 99% the speed of light, colliding with a single stray atom of hydrogen is catastrophic. To the starship, that static atom looks like a particle of highly concentrated, lethal cosmic radiation. A microscopic grain of space dust striking your hull at near-light speed would carry the kinetic energy of a high-yield explosive detonation. At those velocities, the interstellar vacuum transforms from empty space into a solid wall of pure destructive force, scraping away at any physical material down to its subatomic components. Even if we assume we can build shields out of exotic matter to deflect interstellar dust, we cannot bypass the temporal mechanics of the universe: time dilation. Einstein's special relativity dictates that as an object moves faster through space, its movement through time slows down relative to a stationary observer. If you are aboard a starship traveling at 99% the speed of light, time for you slows down dramatically. Let's run a thought experiment. You launch a mission to a planetary system located 50 light-years away. You travel at near light speed. Because of time dilation, the clocks on your ship might register that only 5 years have passed during the journey. To you, the trip was quick, manageable, and highly successful. But when you open a communication channel back to Earth, you discover a horrifying truth. While 5 years passed for you in your high-speed bubble, a full century, 100 years, has elapsed on Earth. Everyone you ever knew, every friend, family member, and the entire generation that cheered at your launch has been dead for decades. The culture, the politics, and the technology of Earth have moved on completely without you. You have effectively traveled into the future, but it is a one-way trip. You can never go back to the world you left behind. The speed of light, c, is often thought of merely as how fast photons travel. But physicists view it differently. It is the speed of causality, the absolute maximum speed at which information, gravity, and cause and effect can propagate through the fabric of space-time. If a star 100 light-years away collapses today, the gravitational and visual information of that event cannot reach us for a century. It is a hard ceiling built into the source code of reality. Because of this ceiling, the universe is fundamentally disconnected. If we establish a colony around a star 500 light-years away, and they send an emergency signal back to Earth, that signal takes 500 years to reach us. By the time our rescue fleet arrives, a millennium will have passed. Interstellar travel ensures that any civilization attempting it will instantly fracture. A colony ship sent across the Gulf becomes an evolutionary and cultural ghost. Communication is impossible, trade is economically absurd, and centralized governance is a mathematical myth. The speed of light doesn't just limit our velocity, it ensures that a unified interstellar empire can never exist. We are destined to remain isolated in our immediate solar domain. When the brutal realities of near-light speed travel become clear, futurists often pivot to an alternative method. We will accept the slow journey. We will build generation ships. A generation ship is a massive, self-sustaining artificial world traveling through the void at a fraction of a percent of light speed. The original crew who launches from Earth will live, reproduce, age, and die on the ship. Their children and grandchildren will do the same. Finally, after thousands of years, the 20th or 30th generation will arrive at the destination planet. It sounds profoundly romantic, a modern Noah's Ark carrying the seeds of humanity across the dark. But when you subject a generation ship to rigorous psychological, biological, and engineering analysis, you hit a catastrophic barrier, the generation ship paradox. The first issue is ecological closure. Designing a closed-loop life support system that functions with 100% efficiency for 5,000 years without any external resource input is borderline impossible. Every single atom of carbon, every drop of water, and every molecule of oxygen must be perfectly recycled. If the system suffers a leakage of just 0.001% per century, the ship will run completely dry of life-sustaining elements long before it reaches its destination. Furthermore, biological life under closed conditions faces massive mutation risks. If the crops or algae cultures used for food and oxygen production suffer a catastrophic genetic mutation or blight, the entire human cargo starves within weeks. If we look past mechanical and biological failures, the greatest threat isn't the machine. It is the human mind, psychological decay. The children born in the deep mid-voyage of a generation ship will have never seen an actual sky. They will have never smelled real soil, seen an uncontained ocean, or experienced a natural ecosystem. To them, Earth is just an ancient myth, a compressed video file left behind by ancestors they never met. Their entire reality consists of metal bulkheads, artificial lights, and recycled air. Sociologists predict that within a few generations, these isolated societies will suffer deep existential nihilism, social collapse, or civil war. The crew will inevitably ask, why are we condemned to live and die inside this metal cage for a mission we never chose, to reach a planet we will never see? And the paradox contains an even crueler irony, the technology leapfrog effect. Imagine you launch a generation ship today that travels at 1% the speed of light. It will take 400 years to reach its destination star. Meanwhile, back on Earth, the population continues to advance. 100 years after the first ship launched, physicists discover a breakthrough in propulsion, allowing them to build a new ship that travels at 10% the speed of light. This second ship launches a century later, but due to its superior speed, it easily overtakes the original generation ship mid-voyage. When the exhausted descendants of the first ship finally arrive at their destination after 400 years of suffering, they will look down at the planet only to see advanced human cities, skyscrapers, and a welcoming committee waiting for them. The entire sacrifice of the intermediate generations is rendered completely meaningless because technology does not stand still. We are trapped in a logical loop where the slow journey is obsolete before it even begins, yet physics forbids the fast journey. At this point in the realization, space enthusiasts point to theoretical physics and say, "We won't travel through space at all. We will build an Alcubierre warp drive. We will warp space-time itself." In 1994, Mexican physicist Miguel Alcubierre formulated a mathematical solution to Einstein's field equations. He posited that while nothing can travel through space faster than light, space-time itself has no speed limit. By creating a warp bubble that contracts the fabric of space-time in front of a ship and expands it behind, the ship could effectively ride a wave of space, moving faster than light without violating relativity. It remains the ultimate holy grail of theoretical propulsion. But when you take this elegant mathematics and attempt to translate it into physical reality, the warp drive reveals itself to be a cosmic illusion. The primary obstacle is the requirement for negative energy, or exotic matter that possesses a negative mass. To understand how absurd this is, imagine an object that weighs -10 kilograms. While negative mass works beautifully in abstract whiteboard calculus, there is not a single shred of empirical evidence that exotic matter actually exists anywhere in our observable universe. It is a mathematical ghost. Even if we assume quantum fluctuations can be engineered to harvest microscopic amounts of negative energy, the scale required is astronomical. To maintain a warp bubble large enough to hold a modest starship would require converting the entire mass of the planet Jupiter into pure negative energy. Harnessing that level of power is completely beyond the physical limitations of a planetary civilization, but the most terrifying aspect of the Alcubierre drive is known as the particle annihilation problem. As the warp bubble moves through space-time at superluminal speeds, it sweeps up all the cosmic debris, interstellar dust, and high-energy photons in its path. Because the bubble is moving faster than light, these particles cannot penetrate the front wall of the bubble. Instead, they become trapped, accumulating along the forward event horizon like snow in front of a plow. The moment the starship reaches its destination and deactivates the warp drive, the bubble collapses. In that exact instant, all the accumulated high-energy particles are released simultaneously in an incredibly concentrated forward-facing beam of lethal cosmic radiation. This blast is calculated to be so powerful that it would instantly vaporize the atmosphere, biosphere, and surface of the very planet you were trying to visit. The warp drive is not an instrument of exploration. It is accidentally a planet-killing weapon. If humanity cannot cross the stellar gulfs, we must ask if any super-advanced extraterrestrial intelligence has managed to solve this puzzle. To explore this, we utilize the Kardashev scale, proposed by Soviet astronomer Nikolai Kardashev. He categorized advanced technological civilizations based on their total energy consumption. A Type 1 civilization can utilize all the energy available on its home planet. A Type 2 civilization can harness the entire energy output of its host star, typically by constructing a massive megastructure known as a Dyson sphere. A Type 3 civilization moves beyond its stellar cradle, controlling the energy dynamics of its entire home galaxy. If a Type 3 civilization exists, they must have engineered a way to bypass interstellar limitations. They might employ stellar engines, Vishal systems like Shkadov thrusters that use balanced stellar radiation to slowly navigate their entire solar system through the galaxy like a giant cosmic ship. But an unyielding law of physics acts as a barrier to even the most advanced galactic empires, the second law of thermodynamics: entropy. No matter how advanced your technology becomes, you cannot escape the generation of waste heat. Every computation, every starship launch, and every mega-scale engineering project releases thermal radiation into the vacuum of space. If a Type 3 civilization were actively running a high-speed interstellar network across a galaxy, their cumulative waste heat signature would glow brightly in the mid-infrared spectrum. In a massive effort to locate these galactic empires, astronomers conducted the G-HAT survey, scanning thousands of distant galaxies for anomalously high mid-infrared signatures that would indicate widespread stellar engineering. The results were chilling. They found absolutely nothing. Every single galaxy surveyed appeared completely natural, cold, and quiet. There were no signs of grand cosmic networks or Type 3 civilizations. This leads to a profound conclusion. Either Type 3 civilizations are impossible to achieve, or the moment an intelligence reaches the limits of physics, it realizes that wasting vast quantities of energy attempting to conquer the physical distances of interstellar space is a pointless, obsolete endeavor. Instead of expanding outward into the cold dark, they likely turn inward, optimizing their own solar systems, living within highly advanced virtual realities, or manipulating matter at the quantum scale where distance ceases to matter. They choose to adapt to the universe rather than wage an energetic war against its scale. This brings us face to face with the most haunting question in modern science, the Fermi paradox. If the observable universe contains roughly 200 billion trillion stars, and billions of those stars host terrestrial planets inside habitable zones with the right chemistry for life, then where is everybody? Why is the night sky defined by a deafening absolute silence? We point our most sensitive radio telescopes at the stars, expecting to hear a crowded cosmic chorus, but we receive nothing but the empty hiss of background radiation. To explain this great silence, scientists often evoke the Great Filter theory. This concept suggests that there is an incredibly difficult evolutionary barrier or technological hurdle that prevents life from developing into an interstellar civilization. Perhaps the emergence of single-celled life is the filter, or perhaps intelligent species inevitably destroy themselves through nuclear conflict, climate collapse, runaway artificial intelligence, or biotechnology before they can leave their home worlds. But when we look at the physics of distance, a different answer emerges. The Great Filter might not be a biological disaster or a weapon. The filter might be space itself. The universe did not place light years of distance between stars out of mere coincidence. That emptiness is a fundamental property of space-time architecture. Every solar system is a self-contained island. Even if a civilization develops high-powered radio communications, those signals degrade, scatter, and fade into background noise across interstellar distances. By the time a signal from a distant star system reaches Earth, it is so weak that it is entirely indistinguishable from the random static of the universe. We are not necessarily alone in the universe. We are simply too far apart to ever know each other exists. Civilizations may rise, build radio towers, look out at the void, and slip into extinction, completely unaware that another lonely world was doing the exact same thing just a few light years away. Distance ensures that life remains permanently quarantined in its place of birth. Everything we have discussed so far assumes the universe is a static stage, a vast, unmoving room where the stars remain locked in place. If that were true, then perhaps over millions of years of robotic exploration, self-replicating probes could slowly crawl across the galaxy, but the universe is not static. It is expanding, and this expansion is the ultimate mechanism that renders interstellar travel completely, undeniably obsolete on a cosmic scale. In the 1920s, Edwin Hubble discovered that distant galaxies are moving away from us. Decades later, in 1998, astrophysicists studying distant Type Ia supernovae made a discovery that completely upended our understanding of reality. The expansion of the universe isn't slowing down due to the pull of gravity, it is accelerating. Something invisible, pervasive, and incredibly powerful is stretching the very fabric of space-time apart. We call this force dark energy. To visualize this acceleration, imagine a rubber sheet with dots drawn on it. When you stretch the sheet, the dots move apart from one another. The dots aren't actually moving across the rubber, rather, the medium they sit on is expanding, because space is stretching uniformly everywhere at once. The more space there is between two objects, the faster they move apart. On a local scale, gravity keeps things held together. Our local group, which includes the Milky Way, Andromeda, and about 50 small dwarf galaxies, is tightly bound by gravity, so dark energy cannot pull us apart. In fact, the Milky Way and Andromeda are currently on a collision course. But beyond our local group lies the true expanse of the cosmos, trillions of other galaxies stretching across the observable horizon. And every single one of them is being carried away from us by the relentless expansion of space-time. This brings us to the ultimate boundary of our reality, the cosmic event horizon. Currently, any galaxy located further than approximately 16 billion light-years away from us is expanding away at a speed that exceeds the speed of light. This does not violate Einstein's relativity. Relativity states that nothing can travel through space faster than light, but space itself has no speed limit. It can stretch at whatever velocity it pleases. What this means for our future is absolute. If you stepped into a starship tonight that could travel at 100% the speed of light, and you flew directly toward a galaxy beyond that 16 billion light-year line, you would fly for an infinity of years and you would never arrive. The space expanding between you and your destination would grow faster than your ship could ever cross it. Trillions of worlds are already permanently, irreversibly out of our reach. As time moves forward, this situation does not remain stable. It grows increasingly bleak. Because the expansion of the universe is accelerating, our cosmic event horizon is constantly shrinking in terms of what we can physically access. Every single day, thousands of stars, solar systems, and entire galaxies are crossing over that invisible line. They are slipping past the cosmic veil, entering the zone where the space between us is stretching faster than light can cross it. We are watching a slow-motion cosmic eviction. We are being systematically isolated from the rest of the universe. Astronomers calculate that every single year, millions of stars leave our reachable universe forever. Currently, an astonishing 94% of all galaxies in our observable universe are already permanently out of our reach. No matter what science fiction technologies we invent in the future, 94% of the cosmos is an absolute no-go zone. We are trapped in the remaining 6%, and that window is closing fast. Let's project this cosmic timeline forward by a few 100 billion years. If our descendants manage to survive within our galactic neighborhood, they will look up at a night sky that looks fundamentally alien to ours. The accelerating expansion of dark energy will have pushed every single galaxy outside of our local group past the event horizon. The light traveling from those distant galaxies will be stretched so severely by the expanding space-time that its wavelength will shift completely out of the visible spectrum, moving into the infrared, then radio waves, until it becomes entirely undetectable. The cosmic web, the massive glowing filaments of matter that connect the universe, will dissolve into absolute nothingness. The lights of the universe will go out, one by one, separated by horizons of infinite distance. Future astronomers living in the merged Milky Way Andromeda galaxy will point their most sophisticated instruments into the deep dark, and they will see absolutely nothing. No distant spirals, no colliding galaxies, no remnants of the Big Bang. They will find an endless, terrifying void. Their physics textbooks will conclude that their galaxy is the only thing that exists in the entire universe. They won't even know what they've lost. They will have no record that trillions of other worlds once danced just beyond the darkness. The accelerating expansion of space will have completely erased the rest of reality from our history. When confronted with the massive walls of the microscopic universe, theoretical physicists often seek refuge in the microscopic world. They ask, can we cheat space-time through quantum mechanics? Can we construct quantum wormholes to bypass distance entirely? In theoretical physics, Einstein-Rosen-Bridges wormholes represent a valid mathematical solution where two distant points in space-time are folded together, creating a shortcut through a higher dimension. If we could stabilize such a structure, we could step through a portal on Earth and instantly step out onto a planet on the other side of the galaxy, completely bypassing the physical distance. But quantum field theory steps in to smash this final hope. To keep a wormhole open wide enough for a human or a spacecraft to pass through requires the deployment of exotic matter with negative energy density to counteract the intense gravitational forces pulling the throat shut. As we established earlier, negative energy is an unproven mathematical concept. Furthermore, quantum mechanics introduces the problem of feedback loops. The moment a wormhole forms, quantum vacuum fluctuations inside the throat begin to amplify exponentially. Photons and virtual particles loop through the shortcut infinitely, creating a runaway surge of energy similar to the screeching audio feedback you get when you place a microphone too close to a speaker. This surge creates a massive gravitational collapse, causing the wormhole to instantly snap shut into a microscopic singularity before even a single atom of information can pass through. If we look even deeper, down to the Planck length, the absolute smallest scale of reality, space-time ceases to be a smooth, bendable fabric. Instead, it dissolves into a chaotic, fluctuating environment known as quantum foam. At this scale, the very concepts of cause and effect, time and distance break down completely. Nature has locked every single door. On the macro scale, we are blocked by the ultimate speed of light and the accelerating expansion of space. On the micro scale, we are barred by quantum instability and thermodynamic degradation. Interstellar travel is not an engineering problem waiting for a clever solution. It is a fundamental architectural limitation built into the very design of our cosmos. This leaves us with a profound existential realization. Interstellar travel is an obsolete concept, not because our technology is primitive, but because the universe is fundamentally designed for separation. It is a vast system of cosmic quarantines where civilizations are born on isolated islands, look out at the stars, and fade away without ever making physical contact. It is incredibly easy to find this truth depressing when you look at the cold numbers, the trillions of miles of hostile emptiness, and the accelerating void. It feels like our existence is completely insignificant. We are brief sparks of consciousness in an ocean of expanding darkness, temporary, fragile patterns destined to be swallowed by an absolute freeze. But there is an entirely different way to view our place in time. The very fact that the universe is tearing itself apart, the very fact that this cosmic window is temporary, makes our presence right now extraordinarily rare and precious. We live in the absolute golden window of cosmic history. We live in an era where the universe is still close enough to be seen and understood. We can look through our telescopes and chart the distant galaxies. We can read the history of creation written in the cosmic microwave background. We can deduce the hidden mechanics of dark matter and dark energy. The civilizations that may arise billions of years from now will be born into a completely black void. They will have no way of knowing that other galaxies ever existed. They will be blind to the grand history of the cosmos. But we are here now at the perfect moment, witnessing the universe in its full majestic glory. We are the universe noticing itself. We are the precise configuration of stardust that developed brains, consciousness, and the capacity to look back at the void and decode its laws. Our physical starships may never leave this immediate solar cradle. We may live out our entire history as a species within the confines of a few light years. But our minds, our curiosity, and our science can span the entire 93 billion light-year expanse. We do not need to conquer the stars to belong among them. Sitting on our tiny pale blue dot, trapped by the laws of physics, we have still managed to comprehend the very forces that are tearing the cosmos apart. And that is not nothing. That is everything. Thank you for joining me tonight on this massive, late-night deep dive into the terrifying physics of cosmic emptiness here on Dark Matter Nap. If this exploration challenged the way you look at the night sky or made you appreciate our fragile place in the dark, please take a moment to like this video and subscribe to the channel. Your support helps us continue to create these deep, quiet journeys into the mysteries of existence. The next time you look up at the stars, do not look at them as destinations we will someday conquer. Appreciate them because they are beautiful, fragile lights shining briefly in a vast, expanding dark, shining just for us, just for now. Sleep well tonight, knowing that we are the conscious eyes of an expanding universe. Good night, and may your dreams reach far beyond the uncrossable horizon.